Hello, everyone. Thank you for joining us. My name is Max Kaneski, and I'm the founder of OpenCDISC and the president of Pinnacle 21. I'm very excited to welcome everybody to our first OpenCDISC webinar. We're hoping this is the first of many to come. These webinars will be educational events around the OpenCDISC growing platform of tools. With this first one, focusing on the new Define.xml tools available on our platform. The OpenCDISC webinars is not the only events that we're planning to hold. Some of you might have attended an OpenCDISC Live event in Boston a few months ago. So in addition to the online webinars, we're also planning to hold a number of face-to-face events throughout the year in different locations around the US to give you an opportunity to meet the developers of OpenCDISC face-to-face, interact with the developers, and hopefully give us the feedback we need to grow the platform further. The next OpenCDISC Live events are going to be held in New Jersey and San Francisco. The New Jersey event is going to be hosted by Novartis, and it's going to be on September 9th. The registration is now open. You can register on OpenCDISC.org. The San Francisco event will be hosted by Gilead, and the registration will be available in the next week or so on the OpenCDISC.org website. If you want to stay on top of our events, there's many different ways that you could do that. We have a LinkedIn, a Twitter, and a Facebook page, so you can follow us on those pages for updates on the releases of the software as well as the upcoming events. Also, the Pinnacle 21 blog. This is something we launched about 3 months ago. We'll have a lot of useful educational information about the platform and about things happening in the industry. And, of course, the OpenCDISC.org website is a great resource for staying on top of our events. So what we wanted to do today is talk specifically about Define.xml. We're going to show you a demo of Define.xml Designer. But before we do that, I'm going to spend a little bit of time talking about the importance of Define.xml and why it's important for you to upgrade to version 2.0. At the conclusion of the demo, I'm going to tell you about the differences between the community and the enterprise versions. Most of you already, I hope, know that the OpenCDISC platform now comes in 2 versions, the community, the open source version, and the commercial enterprise version. So I'll make sure that I point out the differences at the end of the demo. And finally, there'll be some time for questions and answers. If you take a look at the top left corner of your screen, you're going to see a little Ask a Question button. You can click on that button anytime throughout the presentation or the demo and put in your questions. This will tally on our side, and we'll monitor them during the presentation. We'll try to answer as many as we can at the end of the demo. Whatever we can't answer, we will collate them, and then we'll respond to everyone over email. Also, if you look at the right-hand side, there's also a full screen button. If you click on that, it'll try to take up most of your screen for a better viewing experience. So let's start with why is Define.xml important? The Define.xml is important to different groups of individuals or organizations. The first organization, the most important organization that really cares about Define.xml is the FDA. If you look at the latest FDA Study Data Technical Conformance Guide, you'll see that they make special note of the importance of Define.xml to the review process, and they even go as far as to say that they haven't been happy with the way Define.xml has been created in the past. So they definitely call this one out as one of the most important aspects of regulatory submission. So why do they think it's so important? Well, there's a number of reasons, and I think it's easier to understand if you look at it from the reviewer perspective. So you receive a submission. It could have as many as 40 studies. There's a lot of custom domains. There's a lot of supplemental qualifiers. How do you know what was actually submitted? This is where Define.xml plays a critical role. Define.xml, along with the Study Data Reviewer Guide, those 2 documents are very critical in helping the reviewer understand what's actually in the submission. So the Define.xml describes the content and format of all of your data sets. It also, and this is an important aspect, it also shows you the traceability between your dataset variables and your annotated CRFs. So it's very important for the reviewers to be able to very quickly jump to the CRF page where your data came from, because that really helps them understand how the data was collected. So what these documents allow you to do is they allow the reviewer to very quickly get familiarized with the submission data. And that saves time. It saves time instead of having them, look through, hundreds and hundreds of data sets and trying to figure out what's going on. They can, really jump in and start doing the review because, they can find the information they need right away. And most importantly for you guys, it avoids unnecessary queries. So, if they can't find what they're looking for, they're going to send you an email. So this is really a time saver for both sides. And finally, from my personal experience working at FDA on the Jumpstart project and the DataFit project, I very often see reviewers print out the Define.xml and use it like a desktop reference. So as they, doing the analysis in the various tools that they have available, they have it laying on their desk so they can flip through and find the detailed information they're looking for. And this is why they're very often asked for the Define.pdf because printing is very important to them. So what are the most common Define.xml deficiencies that I have personally seen at FDA? There's quite a few. I mean, many of the Define.xml, even today, come in a non-compliant structure. So they'll be either missing sections or, sometimes, very rarely, but you can see the ones that are not even valid XML, which I find it difficult to understand how that's possible nowadays with, with OpenCDISC validator tool available for so long. But, there's always, issues with the actual structure. But much more often what you see is there's issues with missing incorrect or inconsistent content. Very often you see CRF pages that are either missing or they're actually inconsistent with actual annotated PDFs, CRFs. We also very often see that the control terminology is not included or it's only part of it is included in the Define.xml. We also see that the methods are not always described. A lot of people just leave them completely out. And then finally, value level metadata. That's always been a sort of the Achilles heel. Very rarely do you actually see high quality value level metadata. From my personal experience, and this has been confirmed by a number of presentations done by various FDA folks over the years, about 3 out of every 4 Define.xml has at least one of the deficiencies mentioned above. So it's quite a significant problem right now. And this is why here at OpenCDISC we're trying to solve this problem by introducing our new tools. And I think, in my personal opinion, I think a lot of these deficiencies are due to, the limitations of Define 1.0, and, migrating to Define 2.0 would be of great benefit. So besides the FDA, who else is interested in Define.xml? I've been always a big advocate of creating the Define.xml early in the process, not just prior to submission. And the reason I think it's a good idea is because it's a great way to communicate expected deliverables when you're working between partners. So if you're a sponsor working with a CRO, this is a great way to describe what you're expecting. You can specify what domains you're expecting to receive. You can even describe using the value level metadata functionality. You can even describe, what tests are expected at each visit. You can even describe, what are the acceptable values for each test. All of that could be done by creating a valid Define.xml. And the great thing about it is that if you do, you can then take advantage of the OpenCDISC validator tool that will automatically run those validations on the study-specific metadata that you created. So it's really a win-win. If you do this early and if you go in and you specify the metadata to the level of detail, you could really benefit a lot from getting high-quality data when you exchange data with your partners. So why should we upgrade to 2.0? I mentioned a couple of items, but like I said before, Define 1.0, it's very old. It's been created quite many years ago. The submission process of FDA hasn't really been perfected at that point, so a lot of the requirements just weren't there when it was created. Plus, as we all know, you never use system version 1.0, right? That's a well-known fact. So just because it's outdated, I think it's time to move on. But there's a number of great reasons why you would like to upgrade. Number one is they finally fixed the value level metadata issue, right? So many of you probably remember that in version 1, you could only pretty successfully define value level metadata in subqual. When you try to do it in findings domains, you had a difficulty specifying whether you were doing it for the original result or standard units. There really was no way of doing it in a machine-readable way. So in version 2.0, they fixed this issue by introducing the where clause. So now you can create any variety of value level metadata with any kind of complex where clauses to describe your data in the level of detail that it requires. So this is probably the number one reason why you would want to upgrade. The number two reason is that the definition of the origin has been made much more formal and clear. Before it was kind of vague. You can pretty much type in a lot of different things into the origin field. Now there's very specific requirements how you're supposed to do CRF pages, how you're supposed to do predecessors or derived columns and so forth. So between the value level and the origin, I think these two reasons absolutely necessitate upgrading to 2.0. But there's also a lot of other great things. You have the references to standard control terminology, so it's very easy to see if you extended a code list or you haven't. There's also many more places where you can specify comments, and those comments sometimes could come in handy during submission process because you can explain something that, if you have some domain that it's a custom domain, you want to explain what it is, you can create a comment for that domain. You can also define your methods in much more robust way. You can actually specify the formal expressions for each one, which wasn't possible in the previous release. And finally, you can really take advantage of external documents. You can put in all of your complex algorithms in a separate PDF document, and then you can reference it from Define. So all of these reasons, in my opinion, they're great reasons for upgrading to 2.0, especially now that tools for Define 2.0 are available. So now that I gave you a little bit of context about what problems we're trying to solve, I'm going to move on to the demo stage. To do the demo, I'm going to introduce you to Travis Callipy. Travis Callipy is actually the head of product development here at Pinnacle 21, responsible for the development of the various OpenCDISC tools. He's the one who's going to give you the demo. But before he begins, I'm going to just give you a little bit of context of what we're going to try to accomplish in the demo. As most of you, as I mentioned previously, there's really two different places where you would create a Define.xml. Many companies today created right prior to the submission. So this is what we call a descriptive approach to Define.xml. So basically you have the data first, then you create a Define.xml. By far, this is the most popular approach today. But then there's a new approach that some organizations are beginning to use, which is creating it up front when they're defining the requirements, when they're working with the CROs, basically a data specification. Here's what I expect. So what we're going to do today is we're actually going to focus on the descriptive approach. And the reason is because this is the most common, so we're going to show you how you can use our tools to solve that problem first. And then we'll hope that in the future webinars, we're going to focus more on the prescriptive model. So with this said, I'm going to leave you with Travis.
All right. Thank you, Max. Hello, everyone. Administratively, I'd like to remind everybody that if you have questions, and we got a lot of questions during our webinar the other day, we'll get back to all your questions. We'll get back to the most common questions when Max wraps up the meeting. Today, I will use Definexml Designer to generate Definexml and Define PDF in a number of different ways. Max mentioned we'll be doing it descriptively, but our tool supports either approach that your organization may use. So the first way I'm going to do it is I'm going to start with a blank study, and I'm going to import sample data from CDISC, which is in XPT files. And like Max said, this is one of the most common use cases we find in the industry today, where organizations wait until the study is done, and then they generate Define.xml with that data as a starting point of the data collected for the study. The other options that I'll be going over is importing an Excel specification. We'll import a Define.xml. We can import either a Define 1.0 specification or 2.0 specification. Whichever way we import it, our tool only exports Define 2.0 because that's what the FDA wants now. And the last option that we have is that we can clone a study. We can copy a study either from just any study that we have or from a standard. So let's jump in. I'm going to create a blank study. So here I am, and I'm going to type in some bogus data for my study name. OpenCDISC Thursday. And I'm just going to copy that to my description and protocol fields, and I'm going to associate that to a standard. We support, as you can see here, all the CDISC standards. We can generate Atom Define.xmls, SDTM implementation guides of various versions, 3.1.2, 3.1.3, 3.2, and send. Another really interesting feature is that you can create your own company, your own organization's standards. And this can be beneficial because the more information you can put into your company's standard, the more enrichments you get when we bring in the data from the XPT files and we marry it to the standard. You can get things like your therapeutic area standards. You can get your custom domains out of the box. You can get codeless applied after I do the import. You can really do a lot to reduce the amount of work that you then have to do on every single protocol. I'll share a few points during the presentation of where you can do that. But for my CDISC sample data, it was associated with 3.1.2, and that's the standard I'm going to select here. For terminology, I'm going to pick the latest SDTM terminology. For language, I'll select English. So here you see a few fields over here, and we recognize that a lot of companies are using Excel for their specifications. And what I'm going to do is show you how you can import that information in a number of different ways, and how our system can really go back and forth with Excel quite easily. So let me pull up a spec that we have, and I'm going to bring in my dictionaries. And Measure is a very commonly used dictionary, of course. I'm going to go over and pull in some other common documents that organizations use. Dictionaries and documents. And where am I getting this, by the way? This is from an Excel spec that you can output from our system. So I'm going to bring in my blank CRF reference document, my reviewer's guide document, and my complex algorithms document. And then I'm going to save my study. And it popped me over to my datasets tab. So at this point, my study is blank, but I just created it. And I'm going to import those XPT files I've been referencing. I'm going to import study datasets. And I'm going to go to OCE demo. And this file has all of the XPTs zipped up for me. I'm going to import. And it's doing a whole lot of work for us right now. And bam, it just populated my datasets, my variables, value level items, codeless items, methods, and comments. History is a separate tab I'll be going into in a little bit. But right now, out of the box, I could export my Define.xml and my Define PDF. However, if I did that right now, it wouldn't be very good quality. So there's work to do to manage the data to get this to be high quality. So I'm going to show you each one of these tabs and how you maintain that data and how you prepare this for a good submission. Before I start going into each tab one by one, I want to describe the interface a little bit. You will see a theme throughout our demo of Excel-like features and interoperability. We did this on purpose because many people use Excel for the specs now, and it's just got some great features. So we've enabled quite a number of those features. Let me show you a few. First, it's got search. So if I want to do a search across all of the fields on the tab that I'm in, I can do that, and I can see adverse experiences shows up. Filter. If I want to use my filters, I can select just my events. I can copy and paste, drag and drop. You'll see plenty of that throughout the demonstration. And I can hide columns if I want to reduce the amount of information that I'm looking at any given time. So it really just provides you very quick, easy maneuverability. I'm gonna do something. I'm gonna make a mistake right here, so that we'll be able to catch it in another feature that we have later. OpenCDISC. I'm just going to tag that on there, and I'm going to save. So I want you to know also about this interface that we purposely left out quite a number of features from Excel because, well, let me just go through them. This tool will not suppress leading zeros on numbers. It will not turn a date into a number, or vice versa. It will not try to autocorrect items like your code lists, which you really want to be spelled in a certain way. I laugh because these have bitten me a few times over the years when trying to generate Define.xml. Sometimes Excel thinks it's smarter and it tries to do things for me, but we don't have those here. We did try to enhance this tool to be better than Excel in a few key ways. First of all, this is not like Google Documents. This is not a spreadsheet stored out in the cloud. This is a 21 CFR Part 11 compliant centralized repository. Having that lets us do quick lookups to other studies to do things like how did I do a certain field on another study, like what is AE description here. I'll show an example of that in a minute. But it lets you not have to go to different network share drives or SharePoint sites or I hope not emails to find the latest version of your metadata. It's a really fast lookup. And there's one other really big thing that we've done. It's key to this whole thing. It's that we enhanced the screen validations so that validation of your data is baked in. It's too easy with spreadsheets that can be 50 tabs wide and hundreds of rows deep to make mistakes and not have them highlighted to you. So that's what our tool does here. So let me show you an example of that. Let's look at AE, and we have an informational message saying a required field description should not be empty. So it's prompting me that I have work to do. I am going to look at another study to see how they did it, because honestly, I might not remember if adverse experiences is the description or adverse events. And we want to compare to other studies or standards to make sure that we have consistency across a large submission. So I'm going to look at a study, and I'm going to copy. Oh, it is adverse events. It's not adverse experiences. Come back to my study, and I can paste it in. So this is our datasets tab. You do the data maintenance just by bringing in the XPT files and marrying it to our standards. We got 34 domains created for us. Let me show you our variables tab. Oh, I have to save before I leave. And you can see here on the variables tab, it brought in 414 variables for all the domains that I have. you might not have appreciated how valuable the search feature might be or the filter feature might be, but seeing it on the variables tab with a lot of rows, it's really helpful. We had a number of questions in our last webinar about how we were able to populate so much data just based on the XBTs and how else did we get the rest. Well, we have, for each variable in each domain, we know from the implementation guide what the label should be. But we actually, because we brought in the XBT files in this case, we bring the label in from the XBT file. And let's take, for example, data type. The XBT files, you can put in that it's like a number or a date, but those aren't the exact formats of those fields that you should include for Define.xml. So when we see it's a number, we marry it to the data, or we check the data to see, is it a float or is it a integer? And we populate the appropriate data type that Define.xml should have. Similarly for dates, it might be a generic form of a date in the SAS transport file, but we profile the date to see which one is should be assigned to your variable. And we also grab the exact lengths. Another interesting field is code lists that are assigned to the variables. We know based on the implementation guide that certain variables are expected to have code lists. And when we see a variable like that, we create a code list and we put it over here in our code list tab. And we find all the distinct terms that were in the SAS transport file and we put them into our code list items tab. Another column I want to go over here, because it represents a lot of work, is the origin column. We know certain origins associated with standards. Study ID, its source, its origin is the protocol. And we have some that are assigned and derived. But a lot of work is creating the CRF pages. Now, some submissions we see to the agency, it just has like CRF populated. And that's accurate, but it's really not useful. Anything I can do to help the data reviewer do their job faster, well, they're going to appreciate it, and they're actually going to be able to hopefully approve your medicine faster. And that's what this is all about. So we highly recommend putting the pages numbers in here. It might not be the most gratifying thing to go through a 100 or 200 page blank CRF page document and find where AE SPID is everywhere. But if it saves them a little time, I'm glad to do it. So at the end of the day, doing that sort of activity, I'm not really feeling great about myself. I'm actually kind of tired and sick of it, so I think it should be automated, and we did that. Let me show you how we can import the blank CRFs so it can recognize where those variables are used. And it's going to populate my pages. Just did a whole lot of work for me that I'm happy not to look at all day. Let me go down here and just show you another field, my labs. You know, we don't know about your studies, but you do. And if you can create your standard for your organization or for your therapeutic area and have these sourced, when you bring in the data, it'll get populated for you. You don't have to do it each time. So that's our variables tab. I'd like to show you the code list tab now. I'm going to come back to the value level tab, code lists. Here you can see we have 94 code lists were created, and some of these are CDISC controlled terminologies and others are sponsor defined. I'm going to go over to our code list items tab where we see all the terms. And it's important that you create your code lists with not just the terms that were in the XBT files. to do it well, you should go through the PDS, the blank PDS, and find those terms which were not selected by the investigator, but they were available. So I'm going to show you a couple different ways that we can do that. I'm going to insert a row, and I'm going to show you how we can do data entry in the system. And I'm going to pause here. You see, the system's going to protect me from putting in bad data. This red column's really bad. It won't even let me save right now because I can't put a term in if I'm not telling it what code list to do. So that's just a feature you can't do in Excel. I'm going to put in AEREL and probably related. And I'm going to save. So you can do data entry, but I'm not a big fan of data entry. If there's another way for me to populate the additional terms that were available to the investigator, I mean, maybe I have those in a spec. Maybe I can get them from an EDC provider to get those in an Excel document or a CSV document. I'd love to import them. And let me show you what we can do with that. I'm going to show you some sample terms here. Code list items template. This template's available. You can download it to match our format to do uploads. And you can see I've made it so that we have 3 that I already entered in the system and 2 that were not selected by the investigator, so I have to get these in. And I'd love to import these, but it's important that I import only the ones that were not already uploaded into the system. So let me show you how we can do that. Import CSV. Now I'm going to choose this option, add any new terms. And I'm going to pick my codeless items template. Yeah, I just want to highlight we, excuse me, I have to take a glass of water. So we allow this option for variables and methods as well, but I'm picking codeless items and add the new terms. And now I have 1, 2, 3, 4. I have all 5 terms to bring in. So I've gone through the codeless, and I want to show you the methods and the comments. I mentioned earlier that if you had those associated to your organization standard, they'd be in here already. But I don't have that because I don't have your organization's methods, of course, unless you're one of our clients. So let me show you again how we can bring in methods. And I'm gonna do something. I'm gonna make a mistake to show you how this thing can catch my errors. I fat-fingered something on here. We'll see how that works out in a minute. I'm gonna paste in my methods, and I unfortunately copied my header row, and it's giving me an issue here saying this is an invalid type. It's a warning. It's in yellow. It's not going to actually prevent me from saving, but this over here, it's referencing a document that does not exist. I did not put that into my study property screen, if you noticed. So it's protecting me from entering bad data. I'm going to remove this row, and I'm going to hit save. So my methods are in there. Next, I'll do the same with my comments. I'm going to copy and paste. And I have my comments. So methods and comments, I can assign them to my variables and my value level items. My comments, I can also assign directly to my datasets. But I'm going to show you how we assign a method to a variable. So I'm coming back to my variables tab, and I want to assign to my useSubject ID. It's saying that method is expected when the origin is derived. So I'm going to pick my method on useSubjectID here. And I see AE-seek here as well. I may as well assign that one. Seek. So I don't just want to assign useSubjectID to AE. I have to assign that everywhere. So I'm going to filter on useSubjectID. And I'm going to drag and drop. I mentioned that's one of the features that we have earlier. And I can apply it throughout all the domains for consistency. So I can hit save. And let's see. That's how you apply your methods. You can do the same thing for comments in your variables tab. Let's take a look at the value level items. This is one of the features enabled in Define.xml 2, and you can see in the case of for Q-vals, characteristics can be much more granularly defined with what code list item it has, and what its text length is. In the case when QNAM is AE treatment emergent. So you can see all of these various choices, variables that are different QNAMs, and Q-vals properties vary for each one. That's our value level items tab. So you don't have to know a lot about Define.xml 2 if you can let the screen walk you through it, really. So give me just one second. At this point, we've really completed the datasets tab, the variables tab, value level, code list items, methods, and comments. We're actually ready to do some exports of our deliverables. So let's check that out. I'm going to export Define.xml. I'm going to save this. Open this up. And there's no surprise here. It's just a typical Define.xml that you're used to looking at. It has embedded links within it. You can see all your trial data sets, comments that we uploaded. You're used to seeing all that, I'm sure. Next, I'm going to export Define PDF, and it's really the same content of the data, but just a different format that some of the reviewers prefer. And this is our Define PDF. Prints out a little bit nicer for some people. So I want to go over another feature we have where you can export all of this information that you're looking at right into Excel as a spec. You might want to do this for a number of reasons. You might want to share this with a partner, a CRO. You can send it around, email it in your organization if people don't use the system as much as you do. But we have all the key tabs that we need. We have datasets, variables, value level, code lists, etc. You can even make changes in Excel. If you really love Excel and you just want to keep doing that, you can make changes in the Excel spec here, and you can upload it back into the system. It'll bring those changes in. So that's where we've exported Define.xml, we exported Excel specification, and the Define PDF. We can import that. We already imported our study datasets. I described how you can export and you can import the same Excel spec right here. Define.xml, I'm going to show you in a few minutes how we can import that. And I showed you how we could import blank CRFs as well as upload CSV files. So what I'd like to do now that we generated our Define.xml is go to the rest of OCE and see how you can benefit from this. This is our OCE product that's been used by the FDA and our clients for a couple of years now. And let's check out view reports for my OpenCDISC Thursday study. And you can see this is what the FDA looks at when they receive your submissions. They get a quick dashboard look at the quality level of your submissions. And they get these reports that show the various things that can slow down or impede their cycle time of what's wrong with your data. Our clients like it because they run this beforehand and they make sure it's going to get passing high quality metrics. But I want to skip through these just because there's one that I care about for today, and that's the study level metadata. I get a big fat 0 on this because I didn't have a Define.xml when I ran it, and I'm going to show you how I can run it and see what we get. I'm going to go to validate. And that's going to take a few minutes to process. So I'm going to show you a few more features while that processes. I'm going to go back into our OpenCDISC Thursday study. Excuse me. And I want to show you how we can run some comparisons. Let's say I want to compare my study with another study, or I can even compare my study with a previous version of my study. That might sound sort of funny, but over time, as you have different data cuts, you're working with a CRO, or you do an interim analysis and you're moving toward a final freeze, you might want to see what's changed over time. But I'm going to right now show you compare with another study. And in this screen, you can see a number of features here. You can see CM and DA, this is the study that I did on the right just now with you. These domains were not in the other study at all. AE was in both, but there's something different on this record. And you can see our synchronized scroll lets you see both at the same time. We have, I put this in here so we'd be able to find the difference, if you remember earlier, on our AE domain. And so we highlight in yellow those changes when the key matches. When AE is in both, it shows what's different in yellow, because it's hard to look at it without some color coding. And you see the same over here. There's supplemental qualifiers for AE, but it's blank over here. That's why it shows up. I'm going to show you another tab, variables tab. And over here, same thing. You can see the study ID. I put in some difference on that other study so that we can see that our study, I didn't do that on it. And all the variables from CM and from DA show up because we don't even have that domain, so of course we don't have those variables. Another feature I want to show you, sort of similar to it, but it's the history of what I've done. When I do complex operations, it'll automatically save off the previous version, and I have a new version to work with. It's a control, and I can tell who did what when. Travis made this a little while ago, but I can tell who else was working on the study that way. I can make a new version anytime I want so that my version gets snapshotted away, and it's going to remain there. I'll do it right now. So I got a new version. It was created manually. We have the reason why it was created, kept with each version. So I showed you the history tab now. I want to go back out and show you a few more. So I want to show you how we can import a Define.xml. I mentioned I do that before. So import, I'm going to import a version 1 Define so that you can see we can get that into our system. Remember, we'd always output a Define 2. And it brought me in, it put me on my datasets tab. We've already gone over these tabs. I don't think we need to go over it anymore. And I want to go back out here and show you again how we can also just copy a study. Let's make a copy of our study that we just made OpenCDISC Thursday. I'm going to clone it. And here it is. It put the word copy at the end of it. So I can go into this and I can edit it and give it a name that makes sense. OpenCDISC comparison. I can edit this as its own independent study now. It's an independent study. I just happen to originate it from all the features of the other study. And at this point, I'd like to go back and check the results of the validation that we kicked off a few minutes ago. Check out view reports, skip through these other important reports, but we're just not going to talk about them today. And I can see that I have a passing grade. It doesn't mean that all my data quality is perfect, but it passes the integrity checks that we're checking for. So with that, Max, that wraps up my demonstration.
Great, Travis, thank you. So now that you guys had a look at the software, what I'm going to do next is I'm going to give you a description of what is actually different between the community version and the enterprise version. I've been watching the questions coming in as Travis was doing the demo, and I'm hoping to answer all of them either during this segment or in the Q segment afterwards. But if I don't get to answer all of them, we'll make sure we'll follow up with the email. So one of the questions we had was, what is actually the difference from the user experience? The open source software, the community software, is always built for the desktop, right? So just like the validator, it's something that you can just unzip and run on your desktop. The enterprise software is web-based, centralized, central repository. So that's always a big difference between our tools. One is designed to be run centrally for larger organizations, and the open source community is designed for ease of use. You download, you use. No IT staff required to install or help you set up. So with the community version, because it's not web-based, how do you enter the data? You enter the data through the Excel template that Travis has shown you a few times. The Excel template is basically a direct representation of the web interface that we have in the enterprise version, except this is something that everybody has on their machines and everybody's familiar with. So that's the primary difference. The open source version is Excel-driven. Enterprise version is web-based driven, except you, of course, have the option to use Excel template in the enterprise version as well. As far as what standards are supported, Travis already mentioned that you can create a Define.xml version 2.0 for all of the CDISC standards. You can create it for SDTM, for SAND, and for ATOM. And that's supported in both the community version and the enterprise version. The only difference with the enterprise version is that in the enterprise version, you can create my company standards, which is basically a customization of one of the existing CDISC standards where you can add your custom domains, custom control terminology, and so forth. I mean, you can even go as far as creating completely custom standards. I mean, a lot of companies I know use SDTM Plus, near SDTM for the exchange that happens prior to submission, usually between a CRO and a sponsor. You can do that as well. So you can create your own standards with your own structure, with your own control terminology. That option is specifically reserved for the enterprise version. Another option that is available to both versions is being able to convert your 1.0s to 2.0s. I know that maybe some of you already have half of your studies in version 1, and your submission maybe is a year away, and you're debating what you should do, whether you should stick with version 1. You don't have to. You can just import, export. You'll have version 2.0. There's very little difference in the content that would require you additional work. It's very minimal work that would be required to convert from 1.0 to 2.0. So we made sure that we made it very easy. We don't want to see people submitting 1.0 for no reason if the 2.0 is now available. And finally, the ability to scan, data profile your data to extract the metadata from your data sets and variables, that option is also available in both the community version and the enterprise version. So just like with the validator, the core component of each tool is open source and freely available. So what does Enterprise actually add? So Enterprise tries to add additional features that will save you time or give you some of those value-added features that especially great for larger organizations or organizations who are really looking to get the most out of the tool. So one of the things, the ability to scan your annotated CRFs to extract the page numbers, that's available in Enterprise only. Being able to merge your metadata from external specifications, so that import CSV option that Travis showed you, that's available in Enterprise. Ability to generate Define.pdf, it's also available in Enterprise. The real-time validation, when he was changing content or pasting, cutting and pasting, and the system in real time would tell you if there's anything wrong, that's only available in Enterprise because we just couldn't do that in Excel. And being ability to run comparisons between different studies or different versions of the same study, or even being able to compare your studies against your standard to see how much it deviates. All of those is going to be available in Enterprise only. And finally, the system will keep multiple versions, or you can yourself create versions if you're planning to make a lot of changes and you want to kind of save the snapshot. And then being ability to track changes between those versions. So that is pretty much the difference between the two versions. So I believe this answered some of the questions we had, but then there's a number of other questions that we received that I'm going to attempt to answer in the next 8 minutes. So one of the questions, and I'm glad to see that the questions from this session is almost identical to the questions we had in the first session on Tuesday, which is good. Maybe we should create FAQs and put them on the website. So one of the questions was about how do we actually extract the metadata from, for data sets. Where does the key variables come from? Where does the structure comes from? So currently, this information comes from the standard. So as far as structure goes, we pulled out what the default structure is in the implementation guide, as well as what are the default key variables in the implementation guide. You do have to go back and you have to update them per your data. So if your structure is described, or if you would like to describe your structure differently from the way implementation guide is going to do it, you can go ahead and do that. But this is where the power of the custom standard comes in. I mean, if you have your things that you have modified from the implementation guide, you can create your own standard, and then that will be used in data profiling instead of what comes out of the implementation guide. Same thing with the domain label or description. Currently, we scan to see what's inside the data set. That's why when Travis loaded the data, some of the domains didn't have a description. And the reason is because the CES data set, there was no label on the data set. So if you fix it in the Define.xml, and then you try to run that study, if you run validation with an OpenCDISC, you will get an error saying that the label in the data set does not match the label in Define.xml. But changing it in the Define.xml tool will not update it in your CES XPT datasets. Another question we had was about the annotated CRFs. How do we scan those? What format should the annotations be in order for it to work? So what we recommend people is that they should use the PDF annotations. This is why it's called annotated CRF. If you use the PDF annotation feature, that is the optimal way of doing it. That's the easiest way for us to scan those. We also support ability to scan annotations that are created as form fields, but we don't recommend that. We feel that that's not the perfect way of doing it. But we will attempt to scan them as well. As far as if you look at what should my text be? Like, do I have to have it formatted a certain way? The answer is no. We don't care how you format your text, what you have around it. All we're looking for is the name of the variables and the name of the value level variables in your PDF. If we find that exact text, we will pull the what page number it was on. So that makes it very robust. So it doesn't matter how you do it, as long as you have the name of the variable on the page, we will pull it out. Somebody noticed that not all of the all of the origins were populated after we imported the CRF. And the answer to that is because not all of those were on your annotated CRF pages, or they were not annotated. So if we weren't able to pull it out, it's one or two reasons. Either those are not collected, they're either assigned, or they come from a lab. So you would have to go and populate those. Or if you have a custom standard that you created where those are, where certain variables are always assigned or always come from the lab, if you have them in your standard, those will be populated automatically. Or there's a mistake on the annotated CRF. So you expect it to be there, but it wasn't annotated. So that's also a good QA step for you to go back to the annotated CRF and see how come it wasn't pulled off. And you'll most likely find that the annotation was missing or it was misspelled. Another question we had was about the code lists. It's one of those things that there's a lot of confusion I see. Some people think that the code list in the Define.xml have to be basically data-driven. So whatever you have in your data should be in your Define.xml. And that's not a correct assumption. What the regulatory agencies actually want is they want to see all the code list terms that you were planning to collect. So everything that was on your CRF pages. And the reason is because a lot of times the information that's not there gives you a lot of information about the study than the information that's there. Right? So if you were expecting, I don't know, to collect males and females, but you only ended up collecting females, then is this a female-only study, or how did you end up having only one of the sexes represented? So it's very important to include all the code list items that you were planning to collect, not just what was collected. So that's a very important. That's described, I believe, in the Define.xml specification as well as the FDA, I believe, the technical performance guide, but I'll have to double check. Another couple of questions we had here, and this was more business questions. What is the price of these tools? Well, the community version, just like the OpenCDISC validator, it's freely available. It's open source. It's always going to be open source. We made that promise 6 years ago, and we intend to keep it. And you're going to be getting more and more tools coming out under the community version that will be open source. The enterprise version, so the Define.xml Designer and enterprise versions, actually is also being provided free of charge to those who already have an OpenCDISC Enterprise subscription. So if you already have if you're already a client for OpenCDISC Enterprise, you'll be getting this module free of charge. So we're not really looking at it as a new tool. We're really looking at it as a way to enhance our existing platform, because as I mentioned in my presentation, if you create a Define.xml and if you create that value level metadata the way you could, it really will drive much better validation. So we're looking at this as a great way to increase the data quality of the data. Another question was, when is this available? Is this available? So the answer to that is the enterprise version, it's already available. So that version is already available. It was deployed a few weeks ago. The free version, the community version, is actually going to be rolled out as part of the OpenCDISC Community version 2.0 release scheduled for the end of September, early October. And if you noticed, I didn't say OpenCDISC Validator. I said OpenCDISC Community. And the reason is because we're no longer about one tool. We have the Validator tool, we have the Define.xml Designer, and there's a few other surprises that I'm not going to mention them right now, that you have something to look forward to. But I can promise you that the OpenCDISC platform is growing, thanks to everybody's support of our project, as well as our enterprise clients who have been supporting us. But this is really enabling us to do more for you, and we're hoping to continue doing this in the future. So with this, and now being 3 o'clock,
we will be sharing the slides.
That's right. Here's another question. Are the slides going to be shared? What we're actually planning to do is we recorded this session, and we will make the recording available to everybody who attended this meeting, as well as the slides. And I believe we're also going to summarize the Q&As, and we will post those as well. Anything else, Travis?
We'd love to hear your feedback. We need to hear what kind of tools you need in the future. So we'll be, like Max said, getting back to all the questions.
Well, thank you once again for everybody joining us. I know some of you joined late at night from Europe, so I really appreciate your support. I'm looking forward to doing this more in the future. Thank you.